Okay. Tamam. Do you have a question about last lecture? Do you have a question about last lecture? We were talking about monosubstituted cycloalkane like cyclobutane, cyclohexane. Do you have no questions? Hey. Larger axial substituent integrate unavailable 1,3 diaxial interaction. Okay. This is slide number what? 16. Yes, the last slide. For the question here, he said, this is the note. Larger axial substituent integrate unavailable 1 through diaxial interaction, destabilizing. Okay. Now, with big, I say to you, with bulky groups like this, more than this, okay? With bulky groups, this conformation is not stable. Why this conformation is not stable? When the bulky group at axial, yes, at axial position. Why? Because there is steric effect between the carbon number 1 substituent and the hydrogen that bonded to the carbon number 3. 1, 2, 3. That meaning we have 1, 2, 3. Here we have a steric effect. We have 1, 2, 3 diaxial steric effect interaction. طبعا steric effect interaction طلب يعني هو interaction تمام. Steric effect. This interaction decrease, destabilize. Destabilize. تمام. شو معنى destabilize؟ يعني decrease stability. تمام. Decrease the stability of the cyclohexane conformation. Just like that. Do you understand now? تمام. Okay. Any position it would be preferred for the bulky group. Any position, axial and equatorial. Very equatorial position. Like this. For this more stable than this conformation. Okay? Why? Because the bulky group, the substituent group, they are at equatorial position. So today, let us start it. Today, we start with the di-substituent cycloalkane. Okay? I give you a note last lecture. The important note, there is no rotation between the carbons of the cyclic compound. Okay? Between the carbons of the cyclic. Okay? There is no rotation. So rotation around carbon-carbon bond for the cycle, just for the cycle in the ring of the cycloalkane is restricted. خلاص, there is no rotation. There is no rotation. So a group on one side of the ring can never rotate to the other side of the ring. As I told you before that. And again, I will explain for you by this. So if we have, sorry. Give me please, thank you. Okay. This, for example, the cyclohexane, okay? If you group here to the up, there is no here between this carbon and rotation. There is no rotation. Look, rotation is restricted. خلاص. There is no rotation. That meaning the upper substituent, for example, this CH3, it will remain CH3 on the upper side. Cannot be rotated to the down. Okay? Cannot be rotated to the down. Okay? This what he said here. That meaning, if you group in the down, for example, like that, in the down, there is no rotation can be happened, and it will be give you this group to the up. There is no rotation. Okay? There is no rotation. So this is the important note. For this reason, if you have like this isomers, cis with trans isomers, I explained for you here, inshallah. If this two group to the up, like that, two group to the up, like that. Okay, now two group to the up, yes, it will remain to the up. Just we have conformation here, chair or half chair or boot conformation. Okay, but the upper groups it will be remain upper, and the down groups it will be remain at down. Okay, there is no rotation. For this reason, if the same group at the same side, it will be what? It will be cis or trans? It will be cis, yes, it will be cis isomer. If the different sides, the group was substituent like that, it will be trans. Okay, it will be trans. If you look at like that, trans. If you look at like that, also it will be trans. Okay, if you look at like that, for example, also it will be trans. All the conformation. Do you understand? Okay. So, again, as a result, there are two different for 1,2-dimethyl cyclobutane One having two CH3 group, where is at a same side, on the same side. This it will be give you what? Give you cis. Okay. At the same side of the ring, and one having the opposite side substituent. The opposite side substituent. This give you any isomer? Give you a trans. Okay. So look to the figure here. A di-substituted cycloalkane. Any cycloalkane, this cyclobutane. Yes? It is cyclopentane or butane? Yes, cyclopentane, we have 5 carbon atoms. Now, cyclopentane has two groups. This group now, both of them, if you look at like that, at the same side or different side? Same side. Why? Because both of them, it is near from you. Okay, it is, that meaning give you cis isomer. It is clear, yes? Cis isomer. This, now, this is far from you, and this group near from you, like that. And this the cycle on the plane of the board, on the plane of the paper, okay, on the plane. That meaning this is near from you, this far from you, that meaning this Arduca and opposite side, and this give you a trans isomer, okay, give you trans isomer. A and B are isomers. Which isomers? Not different compound. Yes, because they have same molecular formula, okay, same chemical formula, same molecular formula. A and B are isomer because they are different. Whereas different compound with just the arrange of the atom in the space. Look, the same molecular formula, same molecular formula. Where is the different? The different in the measure? Yes, the different where is? Represent the second measure class of the isomer called stereoisomers. And we know what meaning stereoisomers. What is the definition of the stereoisomers? Compound, same molecular formula, same bonded between, arranged between the atoms, but the position on the space, it will be different. The position, we said conformation. The conformation, it will be different. This is the meaning for it. Okay, stereoisomers are isomers that are differ in way, whereas the atoms are oriented in the space. The position of the atom in the space, just like that. Okay, now my hand here. This is the different position. Okay, different position. So the prefix cis and trans are used where is any time to distinguish these stereoisomers. Like alkene, if you remember the alkene. Yes, the alkene we have cis trans. Why the alkene we have cis trans? Do you know why? Anyone can give me answer? Why مثلا alkyne there is no cis trans? Why alkane there is no cis trans? Why alkene we have cis trans? Okay, what is the work of the double bond? Have a double bond, yalla. Have a double bond. Okay, what is the work of the double bond? Which is a double bond cis trans هي. جنكو؟ carbon bond هي. طبعا carbon. One the bond is sigma and the other bond is y? Pi. Okay, good. Okay, we have important note here. Why there is cis trans? أظن double bond. No. تمام دولق. Okay, every carbon has 2 substituents. Okay, no problem. Alkane, every carbon has 3 substituents. Alkyne also, every carbon has 1 substituent. Yes, we have important note here. Important note. What I told you when I start the lecture. The about what? Okay. طلبة. The alkene, this is the alkene, has cis trans because there is no rotation between the carbon, double bond carbon. There is no rotation. Look, the rotation will be restricted. The rotation, it will be restricted. Okay? The rotation, it will be restricted. Okay? There is no rotation between carbon, double bond. For this reason, if you have like that alkene, okay, like this alkene, both the group at the same side, it will remain at the same side. There is no rotation. Okay, it will give you what? Give you cis isomers. If your substituent at different side, this is the double bond, I have a double bond. They are in the different side. Okay, there is no rotation. Look, there is no rotation. That meaning it will be trans, remain trans, or cis, remain cis. Okay, because there is no rotation at carbon double bond. Okay, so the prefix Cis isomers has two groups at the same side of the ring. The trans isomers has two groups on opposite side of on the ring. خلاص, this is the cis and the trans. Cis and trans want to dimethyl cyclopentan. This also can be drawn when as if the plane of the ring goes through the plane of the page. What meaning that? He said if you ring, now this is the plane. Imagination, this is the plane, okay? This is the plane. If you put the ring like that on the plane, okay, on the plane, that means you have a group here near from you, and you have a group at the back side, far from you. But if you ring through to the plane like that, through to, yani perpendicular to the plane like that, okay? Perpendicular to the plane. That meaning this side near from you and this side far from you. What remain? Remain just XY. XY, this up, this down. This up, this down, okay? Also from this side, from here, like that. Do you understand? Do you understand? But this figure put the cycle throughout to the plane, yani perpendicular to the plane like that. And he put the groups to the up and down to the cycle. If the two groups at the same side, it will give you what? Cis. If the two groups are different side, it will be trans. It is clear for you? This is another way to draw the cyclic compound. Another way, okay? You can draw it like that, and other Nizika near from you, and this in the backside far from you, near from you. Or you can draw in like that, and up to the down. The substitute will be up to the down. There is no dashed here. There is no dashed here. Why there is no dashed? The wedge is this, the wedge near from you. The dashed, this it will be dashed. Okay, this it will be dashed. So cycle, it will be three bonds dashed for cyclohexane, and the 3 bond which near from you. What remain? Remain XY. XY, it will be up to the down, yani on the plane, sarsabura, on the plane, up to the down. Okay, on the plane. Okay. Now, the homework. Look to this homework. Draw the structure for each compound using what? Wedge and dash. Here he told you you have to use this. Okay, you have to use wedge and dash it. For example, cis 1,2-dimethyl cyclopropane. Okay, cyclopropane, you know, is 3-member rings. 3-member rings, يعني حلقة ثلاثية. 3-member rings, and 1,2-dimethyl cis, يعني both of them at the same side. You can put dimethyl wedged, or you can dimethyl dashed as you want. Okay, as you want. حلقة. B trans 1-ethyl 2-methyl cyclopentan. This is the B. This also. What we have, you have two substitutes. One of them methyla, and the second is what? Methyla. Okay? Have ethyl, have methyl. Haka ethyl and methyl at the same side, give you cis isomer. At different side, give you a trans. Second homework. What? Eh? So there. Okay. For example, the first homework, this is the first homework. Amana cyclopropane. Here's other cyclopropane. Okay. Put both of them like that. Cis, this is the cis. Okay? This is the cis. Now, the two substituent near from you, yes? Near from you. And the cyclic at the plane of the board. At the plane of the board. Okay? That meaning this it will be wedged, and this it will be wedged bond. And here on the back side, it will be what? This, the hydrogen, this hydrogen, it will be dashed. خلاص. وأو يدي بنا solid. Okay, this it will be solid. If you try to use this system, you can put it like that. Okay? And to the group to the up and to group to the down, as you want. Okay, as you want. But you have to try. You have to try. Now, the disubstituted cyclohexane. Now we talk about the cyclohexane. The same, if you have cyclohexane or cyclopentan or cyclobutane, the same system. But in cyclohexane, what we have here in cyclohexane, do you remember? what we have here? We have chair form, chair or boot or chair form. You have two chair form, okay? But in cyclopentan or cyclobutane, there is no chair form. This is the different here, okay? This the different here. The situation will be just more complex for you, more difficult, but also we have a procedure to draw the isomers. Now, disubstituted cycloalkane like 1,4-dimethyl cyclohexane. 1,4. Look what he said here. 1,4. Put you 1,4 chinko that substituent at carbon number 1 and 4. Okay. We have how many types of disubstituted cyclohexane we have? This 1,4 and 1,2 عافية and this 1,2 هكذا group very. Okay. This here 1,2. وهذا 1,4. What mean? What remain? What remain? 1 3 هيا عنا 1 3 هيا عنا بوتشينينا. Can be happened or no? Yeah. No. Okay, look to the cyclohexane. This is the cyclohexane. If I say to you cyclohexane, yes, no, not about chair. I will just give me one. I will told you cyclohexane with disubstituent. How many probability to arrange or to put the substituent on the cycle? If you put it here and here, it will be give you 1,4. Yes? Then 1,2, where is it? Here and here. Tamam? Another probability, where is it? 1,4. 1,2. Eh? وهير ايه 1 3 زين هذا 1 3 وهردو صار نفس كربون 1 1. That meaning we have 4 probability to put the substituent on the cyclohexane. We have 1 1 هردو كسر at the same carbon. We have 1 2 and we have 1 3 and we have 1 4. Do you understand? We have 1 4. Here in this example he talked about just 1 4, not 1 1, not 1 2, not 1 3. 1 4 disubstituted cyclohexane is also give you cis and trans stereoisomers. Also the same thing, give you cis and trans. Look here, this is the figure. The methyl group, both of the methyl group at the same side or different side? This. Why? This CH3 near from here and this in the back side. Okay, that meaning they are in different side on the cycle. That meaning it will give you what? Give you trans isomers. This is trans isomers. If the hardo CH3 like this, which that meaning hardo at the same side and this side, and this give you what? Give you cis isomers. Give you cis isomers. So to draw both conformation, if I told you give me or draw for me the conformation of the cis and the trans for the dimethyl cyclohexane. Okay, dimethyl cyclohexane. That meaning, just I will give you here the note. That meaning, if you have, for example, like that. Now, this, both of the group are the same side or different side? Same side. Now, if I made chair form, this chair form. Now, this cis or trans? Cis. Now, also cis. Now, cis. Look, but one of them axial and one of them equatorial. Here, بالعكس. This axial, this equatorial. Okay, that meaning both of them cis. Ava cissa or ava cissa, but an axial and equatorial position. Okay, يعني the position it will be different, but at the plane, both of them upper to the plane of the cycle. Okay, cis, ava cis. Both like that, cis. Okay, both like that. cis. Not بيجي on different side. No, at the up and the cycle. تمام؟ تو بيدنك احترام أخوك وبيدنك. This at don't say it at different side. Okay? Now also this it will be cis. Okay. Now how we can draw the conformation to draw the two conformation of disubstituted cyclohexane. Number one, draw one chair form and added substituent. You have to draw the first chair form and added substituent. Okay, how we can draw the chair form? for trans 1,4-dimethyl cyclohexane trans. Now we talk about what? Trans, about opposite side. Okay. Arbitrarily picks the two carbons located on 1,4 to each other. Okay? 1,4 to each other. Classify them as one, it will be up, and the second, it will be one down carbon of this substituent. Number two, the trans, I will go to the next slide and explain for you, okay? Number two, the trans isomer must have one group above, أو يا مهمة, above to the ring, أو يا مهمة, okay? Above to the ring. And the second one, it will be what? Below to the ring. Now وقت امتحان تيت بيجت أف سيدة شاوة. Okay? One of them, خلاص, trans, one of them above to the ring, and the second is what? Below to the ring. Okay? Below to the ring. The substituents can be either axial or equatorials. Tamam? It will be axial and equatorials. There is no difference, as I show you before that. Cis can be axial, equatorial. Trans also it will be like that. Okay? Axial, equatorial can be happened, but when I told you trans, one of them on the upside and one of them on the downside, خلاص, it will be remain up. Yeah, they remain down. Do you understand? So the easiest trans isomers is visuals has two axial CH3 group. That meaning it will be give you to the next slide. It will be hard to, it will be in the axial CH3 group. This arrange is said to be diaxial. هكا هاردو axial, it will be diaxial. هكا هاردو equatorial, we say di-equatorial unrange. Di-equatorial unrange. Okay? Di-equatorial unrange. So this form, one of the two possible chair conformation. Above just conformation رقم إك. Then what? How we can take the conformation number 2? Just a flipping. Okay, flipping give you conformation number 2. Just in the next slide. Here, look. Now, this if you put here this upper carbon and this down carbon. Okay, this flip to the down and this flip to the up. Give you the second conformation. So if you go to here, look like that. Now, this conformation is chair conformation, yes? Now this CH3 in axial and equatorial position, axial, and this axial. Then this CH3 and CH3 at the same side or different side, as you saw here? Different side. That meaning this is trans or cis? A trans. That meaning this is diaxial conformation. Diaxial. شو معنى diaxial؟ يعني hard substituent at axial position. But is what? Is a trans conformation. A trans isomer. Okay? Trans isomer. If I want just to make a flipping, this it will be go to the up and this it will go to the down. Okay. When this go to the up, that meaning the axial will be converted to what? To equatorial. This, the knot, our knot, I told you before that. Don't forget that. When you make a flipping, the axial atom, it will be equatorial, convert to the equatorial. Equatorial atom, it will be convert to the axial and vice versa. يعني العكس صحيح, تمام? So, when this flip to the up, this axial, it will be give you equatorial. And the axial also here, it will be give you equatorial. Look, di-equatorial conformation. Also, this is trans, but di-equatorial. That meaning the trans here has two different chair form. One of them is diaxial and the second is di-equatorial. يعني وقت امتحان طلبة وقت ما بيجي سيدة أبا here in different side يعني at different side أبا cis or وصا in different side أبا trans نحن خلتها. Okay? Just look to the cycle. Now this to the upper of the cycle and this to the down of the cycle, this give you the trans isomer. Okay, this give you the trans isomer. And this here, we have diaxial. In the axial position, the di substituent at axial position, it will be give you diaxial conformation. بيجي طلبة very trans حتى هنظن. Okay, well, this also di-equatorial conformation. This also trans. This also a trans. يعني hard to trans, but one of them is diaxial chair form and the second is di-equatorial chair form. Do chair form تاعها. تمام? Is it clear for you? So again, by using now this cyclohexane, 1,4-cyclohexane. Look, now this is cis or trans? Cis. Okay, this is the cis. Okay, cis or trans? Cis. Tamam. We go to our example. Change it like that. This is trans. Okay, now it is clear for you. Trans, خلاص. Trans, like that. But if I want to make chair form, look, this it will be axial, and the down also it will be axial. The second chair form like that. One equatorial, and also the second is what? This is slightly difficult, but also it will give you in the equatorial position. This is the equatorial position. Okay, equatorial, and the second it will be axial. You understand? Okay. So this is the trans. If we talk about the cis, that meaning both of them, the cis isomer of the 1,4-dimethyl-cyclohexane also has two conformations. Also have two conformations, okay? As shown here, this figure. Because each conformation has CH3 group axial and one equatorial. صح كده يا cis عكس trans انهردوا axial انهردوا equatorial بينما يا cis one of them axial one of them equatorial. If you change the chair form also it will give you one axial one equatorial. أو ملاحظة مهمة بنفسهم for disubstituted cyclohexane the trans conformation both of them has and two axials in axial position substituent or in equatorial position. بينما in cis conformation, one of them it will be equatorial and one of them it will be axial. The second conformation also one of them equatorial, one of them axial. زين ملاحظة مهمة وصل ترانس ما بين دو قوس يعني اكسيال فارزة equatorial وسيس وصل قوس بكا اوكي it will be axial equatorial or equatorial axial خلاص هذا يعني cis. Because in your exam مثلا I will give you مثلا figures. I told you this it will be cis or trans conformation, okay, and I will show you one of them it will be يعني equatorial or equatorial axial or axial تمام. And by this rule you'll be know this it will be cis or trans conformation if you have problem to imagination the molecules, okay, if you have problems when you look to the molecules يعني on the paper when you read, okay, because some students if you look to this figure cannot be يعني recognized it will be مثلا different side or the same side, but this rule help you to know the position of the groups, can be help you for this reason. Okay, cis isomers has two groups on the same side of the ring, either both up or both down, okay. In this example conformation 1 here, conformation 1, look to the conformation 1 and conformation 2, the CH3 group. If we talk about the stability, look to this and this. Anyone is more stable than other.
Same.
Why the same? Because this is the group now equatorial and this axial. The second conformation, the equatorial will be axial and the axial will be equatorial, and this is the same. Here one axial, one equatorial, axial equatorial, also here one axial, one equatorial. Both of them has same stability. But if you look to the up, anyone is more stable, this or this? Why this? Yes, because the substituent here, the diequatorial conformation is more stable than diaxial. Why? Because the both substituent at yes, we said at room and equatorial room in the space of the equatorial. Diamond. Yes, and the cis, the stability of the two conformation they are same, but in the trans, the stability of the two conformation they are different. Okay, diamond, the diequatorial it will be more stable than diaxial. If I told you why, explain for me. You can explain as you want. Okay, you can explain. This is related with what? any effect. Why this more stable than this? Because that's the steric effect. Any steric effect, 1 3 1 3 1 3 diaxial. Yes, the interaction. This is the reason. 1 3 diaxial interaction, as we told before that. So here, the relative stability of two conformation, as I told you in the substituent cyclohexane, a cis isomers has two substituents on the same side, either both on it will be up in the up position, or both in the down position on the cycle. Okay, a trans isomer in different position, whether substituents are axial or equatorial, depend on the relative location of the two substituents on the carbon. Maybe it will be 1 2, as I told you before that, the disubstituent, and it will be 1 2 or 1 3 on 1 4. طبعا يا هي يجي 1 1 بس 1 1 there is no different. They are يعني 1 2 can give you cis trans. 1 3 also can give you cis trans. 1 4 can give you cis trans. 1 1 1 1 there is no cis trans. Okay, 1 1 there is no cis trans conformation. 1 1 يعني if I give you this, this the 1 1 other 1 1. Okay, 1 1 there is no cis trans, just one conformation other. There is no, but we have chair form, other chair form, or chair form DO, the same thing. One of them axial, one like this, the same stability. Okay, there is no cis trans here. There is no cis trans. There is no cis trans. Now, draw both chair conformation for the 1 3. Look, 1 3 dimethyl cyclohexane. Okay, first chair you can write the chair form, and you have 1 3. That meaning you substituent here and here. طبعا put bond here, one equatorial, one axial, and one equatorial, one axial. تمام؟ أبا تيا نوكا in equatorial position. أبا axial. أبا equatorial. أبا axial. تمام؟ Put, he said, put anyone. Where is it? 1 3 dimethyl trans. This is the trans. The trans, that meaning in different side or the same side? Trans. Different side. That meaning it will be one of them equatorial, and the second will be what? Axial. Okay, خلاص. One of them equatorial, and the second axial. Pick the two 1 3 to each other. Trans isomers has two group on opposite side. أو يا مهمة طلبة. Opposite side. Opposite side. كيش؟ إيه؟ إيه أبا 1 4. Now 1 3. Okay? 1 4. 1 4. This is 1 3. 1 3. Just put the chair form and put this equatorial, axial. This here equatorial, axial. Look here the axial. Here in the front side. If you have 1 4. But 1 3 like that must be one of them CH3 in the down to the cycle, and the second it will be up to the cycle and different side. Yes, the 1 4. Okay? The 1 4. And you can try. I think you have homework about 1 2. You have to also to resolve the 1 2. Okay? 1 2 dimethyl cyclohexane. 1 2 dimethyl cyclohexane. Okay. Okay, this flipping, this it will be flipped to the up, and this it will be when you high, it will be this when you flip this to the up and this to the down. The axial it will be what? Equatorial, and here the equatorial it will be what? Axial. Tamam? Look in different sign. This down to the cycle and this up to the cycle. That's meaning now at your home you have to resolve again. When you come back, you have to resolve 1 4. 1 4 the conformation of 1 4 disubstituent cyclohexane. You have to resolve the 1 2 disubstituent cyclohexane. Give me the two conformation for cis هاردو conformation. يعني cis conformation رقم اك chair form رقم اك و chair form رقم 2. Butrans chair form رقم اك chair form رقم 2. Okay, like that. Also you have to resolve the 1 3. The 1 3 محلولة variable. This for you 1 3, but also it will be يعني useful for you. Okay, useful for you. Now, the axial CH3 flip equatorial still down to the bond, and equatorial CH3 flip axial still at up to the bond. Okay, up to the conformation 2 and 1. Conformation 2 is trans because the two CH3 are still up to the side. Conformation 1 and 2 are equally stable because each has one CH3 axial and another CH3 what? Equatorial. Yani anyone is more stable, this or this? Both of them the same. Buchi both of them the same. Because one axial, one equatorial. Average one axial, one equatorial. هكا مثلا هذا دو axial يعني دو equatorial أو فرق قد هابتون. Okay, but 1 to 1 there is no difference. So label each compound as cis or trans. يلا هذا cis or trans. هذا. هذا trans. Okay, good. If you say this is trans, your answer is right. Okay, trans. Now I want to draw the second conformation.
One is going to be axial.
Yes, this it will be flipped to the down, and this it will be flipped to the up, and draw it. Okay, this homework for you. Now, this cis or trans? Look, I told you before that. If you have a problem, yes, if you have a problem in your imagination, the cycle. Look, now look to this carbon رقم ek. Yes, 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 X-ray Bini. Yes, you're right. Look to this carbon. This Cl up to the carbon or down to the carbon? Up. Okay, look to this carbon. This Cl down. That meaning one of them down, one of them up. Yes, that meaning this is trans. Don't say Cl to Cl near to each other. No, no. But look to the up and down the position of the CH3. Okay? This. Okay, yes, this is. Why? Because this down to this carbon and this also down to this carbon, this it will be give you cis isomers. Then when if you told me this cis isomers, this conformation رقم ek, chair form رقم ek, okay? I want to draw the second chair form also for this the second chair form. تمام؟ خلاص, but we have two subjects here. The oxidation and reduction of reaction. Yes, I will finish here. I will finish here. So, inshallah, next lecture I will talk about the oxidation and reduction for the cyclic compound or cyclic compound. As I told you before that we don't talk about the reactions يعني for the halogenation or mechanism of the halogenation, you take it before that in the alkane, the same mechanism. But here just we take the oxidation and reduction, and the second subject is what? The second one is composition. Yes, the composition of the alkane. طبعا chunko cycloalkane is also alkane, the same composition here, but I will talk because can be entered to this type of the reaction. Inshallah, next day we take these subjects. And do you have a question? Do you have a question? I have to stop now. Stop. Can you stop the mobile, please? Okay.